Okay, well, lesson number 3 is it's about the SQL code that basically started generating right now, or conceptually started to create. Then we'll also go into some other standard statements where you can actually manipulate the data. All right, so basic SQL or SQL, depending on how you want to pronounce it, but you got data statements, which you can do data manipulation. You can select information out of the data. You can insert new data, or you can update existing data, delete it. Basically, what you're just working on right now was the data definition language, which is your create statements. Like you were just doing some create tables when you did that Visio, you did that diagram, ERD diagram. The code behind the scenes, as you already seen, was the create tables. You can also, after the table is created, you can also alter it to add new columns or put new constraints on it. Also, if you can create it, you also can drop it. Another statement up here that's not listed, a trunk table, which is a drop table physically removes the table completely out of the database, and a truncated of the table just eliminates the data, but the structure will stay there so you can use it for later. Then we'll talk a little bit more about constraints and even get into some programs that you can actually store inside the database. One of your most used statements would be your select statement. That will bring out any information that based on what you want to look at and how you want to retrieve it. So basically you're just querying tables and views as well. You can get into a little more complicated select statements, and you can bring the results back in a specific order if you'd like. You can join it different ways. You can have a query inside of a query. You can group by specific values that you want to look at and get specific counts if you'd like. There's ways to union two tables. You can see what intersects two tables, or you can find out what's a minus is not even in either table. And then we'll get into some basic inserts, updates, and deletes. There's various clauses in those. Now, the select statement itself is made up of 3 basic clauses. You got the select clause, the from clause, and the where clause. Select clause is will be all the values of all the values that you want to bring back and use within your program. The from is basically what tables are involved or what views are involved. And the where clause can either do one of two things. It can either join tables together depending on what syntax you use, or it can be a filter and reduce the result set that you bring back. Here's a very simple example. Basically, one table is involved, S, and all you're looking for is every city in that table that equals Rome. So in this case, you're not even joining nothing, you're just looking for a specific value in one table. Different expressions can be used in the select clause and the where clause. So like you can actually call a function inside your where clause if you like. If a function returns true, then give me these values back. There's various different other expressions you can use. The first sample I showed you did not join in tables, it just used one table. So now if you want to bring 2 or more tables together, you can actually start getting into the join. One place you can do join, and we'll get some examples later, could be in the from clause, and that would be like an explicit join. Like I mentioned before, you also can do joining in the where clause, and that would be like a implicit join. You can use various subqueries inside of queries. There's several different ways you can bring them back. Predicate, whether it equals something or not. Scalar, you would bring them back a specific function of one value, or you can bring back a table and query through the table results, all within your from clause. Another useful is grouping queries together. You got several different values that you're interested in, and you want to group those specific values together, you can do group by queries by putting all those same values in the group by clause. Has anybody ever used the group by clause? Okay, it's a pretty useful query. Have you ever tried using the having clause with the group clause? It turns out pretty useful. What the having clause does is it allows you to filter out your group bys based on some type of aggregate, either a count or something like that. So it's kind of a where clause for the group by. Now, when you start doing select statements, it's pretty much boring just select from one table all the time. So where you really get your power out of the select statements is actually joining two tables together or two views together. And basically what you're doing, you're looking for information that is in both tables, some type of correlation. Now this is a pretty basic join. You got two tables involved, but if you just leave it like this, you're going to get some undesirable reviews. You're going to get some undesirable results. I believe all you had a data modeling class already. If you've seen a statement like this, what type of result would you expect to get back? You're just joining two tables together, not on any specific filtering or anything like that. So what you end up with is a Cartesian product. So what that is, that's every row in both tables, every combination coming together. So you got table SP over here, and you got table P over here, and you end up just bringing back every combination, which when you got limited amount of data, doesn't seem to be that much of a problem. But now if you got two tables together, and you end up having 10,000, 100,000 rows in each table, that query could actually bring down your database. So you want to try to stay away from Cartesian products. And how you do that, you start using joins. Now, we'll start with the inner join. Like I mentioned, there's two different ways you can join tables. One is using the where clause, and this type is implicit, so where you're saying everything in where table SP also has a match over in table P, and you just bring back the matching results in this case. So where you can see where you bring back everything, all of a sudden, now you're down to something that's manageable that you can start using. Another type of join is an outer join. Now the difference between an inner and outer join, the inner join brings back everything that matches in both tables, where the outer join now will bring back everything that matches your filter in one table, but it will also bring back everything that matches, but it will also create an arbitrary row of what doesn't match in the other table. And usually when it's an artificial row that comes back, that specific set of values will be set to null, which I'll show you an example in a little bit here. But there's various types of outer joins. You got left, right, and full. And based on whichever parameter you use there, it will depend on which table is the one that will bring back everything and which one will be the one that brings back the arbitrary values. So like in this example here, you got a left outer join, you got P, left outer join on to SP. So being at the left, it's everything on the left side of the word join is going to come back, and the arbitrary table will be the one on the opposite side. So in this case, it's the right side, it'll come back null. Now if you flip-flop that and say, give me a right outer join, it'd be vice versa. You'd bring back everything over in the SP table, and then you'd bring back the matches plus any unmatched stuff over in the P side. Now where the select statement was able to bring information out and you could use it, the insert statement is what you use to put new data into the database. Now there's two types of inserts you can use. One is listing every value that you want to go into a specific table, and that would do one row at a time. In the case where you might want to actually do a whole bunch of inserts at one time, you didn't want to write 10,000 insert statements, you can actually do an insert into the same table, but you can also add a query to the list. So whatever the query results come back, that's what would go in your table. Now where that might be useful is, the example you want to, say you want to back up your customer table or any table at all, you want to back it up before you do something to it, just in case you mess up, you want to put it back the way it was. One of the simplest ways is to do select all on that table you want to back up and give it maybe like a backup, like backup table 1. So you can select everything on table 1 and dump it into your backup. So now you got yourself protected there in case something goes wrong later on. Now the update statement is the statement you use whenever you want to manipulate existing data. So the table information is already there. So usually what you do, you go out, you use your where clause to find a specific row in that table, and what you'd update it with is whatever you state in your set list. Now your set list would be like column A equals 1, column B equals Bob, and things like that. That's what would be in your select list. So that's actually what this slide was getting to here. The one thing that you can do in set statement is you can actually set columns to null, providing there's no null constraint on that column. Now the delete statement's obviously opposite of the insert statement, where the insert is putting information in. The delete row will actually physically remove it out of your database. It'll get rid of it. It'll take it out of whatever table it is. You can only delete out of one table at a time based on whatever your predicate statement is, like ID equals 10. So whatever row had 10 as the ID would be physically removed there. Now, just a word of caution, when you do a delete like this, you probably want to make sure you always have a where clause there, because I don't know if anyone's ever tried that before, but if you just like do delete from table 1, do you have any idea what would happen? Every row in that table is gone. So that's why when you back on the insert statement, that's why you want to do a select all from and back it up. So if you do something like that, then you can put the data back. Another trick that I use in this case when I'm deleting stuff and I want to double check myself and make sure that I don't do the wrong thing, what I'll do is I'll actually make a select statement, and I'll do the select and I'll work on my where clause in the select statement. So that way I know exactly what the results I'm working with. And when I get it to the point that I know those are the exact rows I want, then I'll just copy and paste the where clause into the delete statement. So that way you can, make sure that you don't delete more than you want to. Now, the select, the update, insert, and delete, those are all data manipulation statements. Now, the statement machines we're working on right now, or in the ERD, was actually creating tables and relationships. There's also some other statements you can use. Like I mentioned, the drop table. There's also alter table. Get into a couple other different ones at that point. Also, Jamie was talking about constraints a little bit ago. We'll get into a few more of those constraints. But not only do you have a check constraint, you got the unique and primary key. In most databases, if you do declare something as a primary key, a lot of times that database will automatically give you the unique index as well. So they kind of go hand in hand. But you can be unique without being a primary key. But you can't be a primary key without being unique. Foreign keys, and then there's also a not null constraint, where you're saying this column has to have some type of value. I don't care what it is, but it can't be empty. All right, here's an example of check constraint, which He's already seen one already when Jamie was walking through his lab results. But basically, you make the table, define the column, whatever you want it to be. The alter statement would actually add the constraint. You give it a name, and then whatever the constraint may be. Now, in this case, after you apply the constraint, if I got an insert statement into that table, and I'm saying give me a value of 5, that's going to be a good insert because it met the constraint. Whereas now, okay, I got my value 5 in that table, but for whatever reason I want to update it, I want to make that a -5. But with that constraint being on greater than 0, you try to make that column a negative number, it's going to fail. So that's where the power of the database can actually be useful for you. It's where you can actually build business rules in that into your database that will really enforce the integrity of your database. So like software developers like us can't go in there and mess up the data just by using our programs. So what we're getting at here is have the database use its power to prevent bad data. Primary key, you probably pretty much, since you went through the data modeling already, you probably already know about the primary key. But basically, same thing, you create a table, give a column, and then the constraint you put on is primary key, that column. Now, like I was saying earlier, primary key is a constraint that requires that value to be unique within that column. So if you do an insert into the table, and you insert a 5, the first one's going to go in fine, no problem. If you try to insert the same value the second time, you violated the primary constraint, so the database will stop you from doing anything like that. Foreign keys. What type of constraint this is kind of like a parent-child relationship. You create your primary table, your parent table. You go through the alter, give it a primary key, put some type of data in that table. In this case, we got our value 5 in our table. Now we create a second table. This is the child table. It's going to be dependent on the table we already created. And what you do, you give it a foreign key constraint, but it references back to the same column of the parent table. So what happens is then when you come to insert data into your child table, you can insert the value 5 because you already got that value up in your parent table. Now, somebody comes along and they want to insert a different value, say value 6. Well, that's a good insert statement, but what's going to happen is since there's a foreign key constraint, the foreign key constraint says, I don't allow any values in this table that's not in my parent table. So since we don't have a 6 in our parent table, the 6 is going to fail in this case. Here's, we get into stored programs. These are objects that you can actually create multiple statements within an object and actually manipulate data, bring data out, put data in, move it around, all based on a program that you store inside the database. Now there's various types of programs you can do. Stored procedure, basically that'd be like a C++ program that you would write, but only now you can store it inside the database. Obviously, you got to use the database language. In the case of SQL Server, it's T-SQL. What is it? Transaction. Transaction SQL, but they refer to as T-SQL. Functions, difference between a procedure and a function. Procedure will allow you to manipulate data, but it doesn't return anything. You can pass information back, but there's no return statement in it. Whereas a function, you do your same manipulation and whatever you want to accomplish, but this will actually return some type of value. If it's scalar, or if it's a table, it will return a result set to you. And then the triggers, this is something useful. This is a piece of program that actually attaches to a table. And the trigger is based on events that happen to that table. I'll show you an example of that in a little bit. Now here's an actual stored procedure. This is a SQL server transaction SQL stored procedure. Basically, if you're starting from scratch and creating a brand new one, you'd have a create procedure. This example is assuming you already had it created and you're making some type of change to it, so you use the alter. So either or create or alter procedure will allow you to put code into stored in the database. Now what's interesting here is you can pass information into your procedure and use that, or you also can pass information back out if you prefer. So these variables, these parameters could be values going in or out. In either case, what you can do is now once you got the code inside the procedure here, you can do any type of legal SQL statement, plus the T-SQL program itself has various functions you can call that are already built into it. So you can manipulate your data any way you want. In this case, I'm doing an insert into a log table. So I'm passing in a couple parameters, checking out the parameters to see if they're okay, and based on that information, I'll insert that information into another table. And this all can be called from an outside source, such as a Visual C program or any other application that the user might be using that actually hits the database. Now the functions, like I said, they look similar. Again, you can pass information in and use that information coming in, or you can go out and grab information that's already in the database. But what's different about a function is you actually physically got to return some type of value. Now in this case, returning a data type of money. So what you want to do, whatever information comes in, verify your information coming in, use it whatever way you need to, and then perform some type of SQL statement on it. When you're all done, you get down to the end of the function, the skeleton function will return just one value. So, and that value that you return actually has to match the data type that's up above that you declared it as. Whereas a function based on a table value is, you got the same idea, same concept. You can pass information in now, but when you return something, you got to declare it as a table. Now your table can be made up of one or more columns. In this case, we've got two columns. So I'm going to return a result set that has a table that has a couple columns in it. So when you get down and do all your manipulation in that, when you get done, you return. It's going to return whatever in these column values for you. So your calling program can actually loop through just like a table. So like in your Visual C or your C++ program that called this, that calling program gets the result set back. Now in that program, you can loop through just like you would doing a select statement. So actually what gets returned in this case, it would be like a cursor reference that you can loop through. Now here's I don't know if you've ever got into table triggers or not in any of your classes.
No.
So I remember last year when we did that, no one knew what a table trigger was, so we decided to expand upon this a little bit. So what this is actually the same type of code, it's the same language, but you can actually attach it to a specific table. So in this case, it's attached to trigger test is the name of the table. And what's going to happen, this code will fire based on what event happens to that table. And where you do that, the after statement. Now in some databases, they have two types of events, a before event and an after event. This example here is just the after event. So whenever something happens to this table, after that statement is done, this code will kick in. So in this case, I'm saying after insert, update, or delete. this code's going to run through. Now you can just do an insert, you can just do a delete. So you don't have to have all of them there. So it all depends on the situation of the event you want to capture on that table. Now in SQL Server database, they actually give you two, SQL Server itself gives you two system tables behind the scenes. You don't have to manipulate them or nothing. SQL Server takes care of it for you. One's called insert, one's called delete. Now where that comes into play and what's important about those is you can use a combination of queries on those tables to determine what event actually just happened to the table. So in this case, where you do a select from the insert, if you get a result set back, you know that record just went into the table. The other one is delete. So in this case, I know it was inserted. If I do a select on the delete table, then I get the same result back as I did in the insert, then I know it was updated. I know there was a value before, got wiped out, now I got a new value. So querying both of those tables, you can determine that we did an update on this table. And last existence is if it wasn't in the insert statement, insert table, it was in the delete table, and it was not in the insert table, then you know that record was deleted at that point. So this comes in handy if like you want to keep track of who's making changes to your data. This is one of the tricks we use behind the scenes. We'll attach trigger to whatever table we want to keep track of, and we'll have some log table there. So like we know who inserted something, we know who deleted something, we know who updated something. But you don't have to use it just for that. You can put any valid statement here. So like if you know I'm inserting a new record into the table, you might even want to track what time that record was put into the database. So instead of having the programmer do it, you can let the database do it for you. So if I know I'm inserting something, you can turn around and do an update on that column and actually push a time into there. So after it's all done, and you look at that record, the database put the time in there for you. So going through all this, and knowing that you've already had some data modeling and some SQL classes, do you have any questions or some type of SQL statement that you can't quite figure out, or